British aircraft designer Sir Sidney Cam, creator of the legendary Hawker Hurricane fighter, once said that all modern aircraft have 4 dimensions: span, length, height, and politics. TSR-2 simply got the first 3 right. While Cam was referring specifically to the British Aircraft Corporation TSR-2, a hyper-advanced supersonic nuclear bomber abruptly and controversially cancelled by the British government in 1965, his statement still holds true for all military aircraft. As such aircraft are manufactured at the request of governments, politics thus invariably makes its way into the design process, for better or for worse. On this and our sister channel Highlight History, we've already covered several ill-fated aircraft whose designs were compromised by political interference, unrealistic expectations, or sheer desperation, from the ludicrously dangerous German Messerschmitt Me-163 Comet rocket fighter of World War II to the Bristol Brabazon, Britain's post-war white elephant of an airliner. But as atrocious as these winged failures were, their designers were at least trying to solve a real-world problem. The same, however, cannot be said of one American experimental fighter aircraft of World War II, whose intended purpose was not to help with the war, advance aviation technology, or even to make money, but rather to boost its manufacturer's brand and help them shirk their wartime responsibilities. This is the bizarre story of the Fisher P-75 Eagle, the aircraft designed to fail. Our story begins in late 1941, 2 years following the outbreak of war in Europe. While at this time, the United States was still officially neutral, it was clear to many that they would soon be forced to enter the conflict. This meant turning over American industry to the production of vast amounts of rifles, ammunition, trucks, tanks, ships, aircraft, and other material needed to fight a modern war. For the US Armed Forces, there was one slight problem. At the time, the US aviation industry was far from the industrial juggernaut that it is today, with even the largest manufacturers producing barely 3 aircraft a day. Indeed, in 1937, the entire industry produced a total of only 3,100 aircraft. By contrast, that same year, the nation's automobile industry produced some 4.75 million units at a rate of 3 per minute. These figures led General Henry H. Hap Arnold, commander of the Army Air Forces, to quip that the aircraft industry ranked down among the candy makers in terms of annual dollar volume. Thus, when the United States finally went to war in December 1941, it was to the auto manufacturers that the government turned in order to ramp up aircraft production. Of the big 3 auto manufacturers, Ford was the most enthusiastic. Henry Ford had already ventured into the aviation industry in 1925 with the Ford Trimotor, a highly successful civilian passenger aircraft that formed the backbone of many early airlines. 2 years later, he introduced the Ford Model 2A Flyver, a light, inexpensive single-seat aircraft which he intended to mass-produce as the Model T of the air. Unfortunately, on February 25, 1928, the prototype crashed off the coast of Florida, killing test pilot Harry Brooks and prompting Ford to cancel the entire project. And to learn more about this and other attempts to create a practical flying car, please do check out our previous video, A Plane in Every Garage, The Long and Twisted Road to Flying Cars. Given his obsession with aviation and mass production, Ford jumped at the chance to manufacture aircraft for the war effort, boasting that he could produce 1,000 a day. However, he and the other major automakers were soon to discover that mass-producing automobiles and mass-producing airplanes are 2 very different propositions. For one thing, aircraft are an order of magnitude more complex. While the average 1940s automobile contained around 1,750 parts, the average aircraft contained more than 30,000, and that was excluding the engines, instruments, electrical systems, etc. Aircraft manufacturing also required a great deal more flexibility and back and forth between the designers and the shop floor, especially under wartime conditions when military requirements were constantly changing. A design could never truly be frozen as it could in peacetime. This was especially true when it came to the manufacture of sheet metal aircraft skin panels, a process which, in the days before computer-assisted design, was more of an art than a science. And finally, many of the standard tools used in the automotive industry did not lend themselves well to aircraft manufacturing. For example, when General Motors decided to move crankshaft machining from its newly acquired Allison Aircraft Engine division to its Cadillac facility, it quickly discovered that none of the lathes at Cadillac were long enough to handle the Allison shafts. Large numbers of custom-made lathes and other machine tools thus had to be ordered and installed at great expense. As the editor of Aviation magazine wrote in June 1941, quote, "Anyone who thinks you can turn out an airplane just like automobiles hasn't seen an airplane." It quickly became clear that a different approach was needed. At the time, wartime manufacturing was coordinated by Lieutenant General William Knudsen, Director of Production for the Office of the Undersecretary of War. An expert on mass production techniques, Knudsen had previously worked as an executive for Ford and General Motors before being appointed chairman of the Office of Production Management by President Franklin D. Roosevelt in 1940. In 1942, Knudsen was commissioned into the Army as a lieutenant general, the only American civilian in history to be given such a high starting rank. rank. Deferring to their greater expertise, Knudsen decided to retain the major aircraft manufacturers as prime contractors while farming out production of smaller sub-assemblies to the auto manufacturers. These sub-assemblies would then be shipped to the prime contractors for final assembly. For example, Ford produced parts for the consolidated B-24 Liberator heavy bomber, Chrysler and Hudson the Martin B-26 Marauder medium bomber, and General Motors the North American B-25 Mitchell medium and Boeing B-29 Superfortress heavy bombers. And over the following years, these companies' aviation manufacturing operations would expand further still. For example, General Motors purchased the Allison Engineering Company of Indianapolis and Engineering Products Inc. of Dayton, Ohio, manufacturers of V-12 aircraft engines and propellers respectively, and owned considerable stock interests in North American Aviation and the Bendix Corporation, a major manufacturer of radios, autopilot systems, and other electronic equipment. And in early 1942, the corporation created the Eastern Aircraft Division, whose facilities in Linden and Trenton, New Jersey, Baltimore, Maryland, and Tarrytown, New York, were tasked with producing Grumman F-4F Wildcat fighters and TBF Avenger torpedo bombers for the US Navy. Yet despite the huge contributions the big three automakers were making to the war effort, their executives faced a massive problem. They weren't getting enough credit. For while GM may have been cranking out huge volumes of B-25, B-29, and F-4F airframes and components, the completed aircraft still bore the names of North American, Boeing, and Grumman, not Chevrolet, Buick, or Cadillac. This was no way to build a brand image, especially when the end of the war would surely bring a surge in civilian automobile sales. So, in late 1942, GM set out to fix this problem by producing an aircraft that would prominently bear their own name. In January 1941, GM hired Don Berlin, former director of engineering for the Curtiss-Wright Corporation. A well-respected aeronautical engineer, while at Curtiss-Wright, Berlin had been the chief designer of the P-40 Warhawk, at the time the United States' Army Air Corps' primary fighter, and later the third most produced American fighter of the Second World War. On joining General Motors, Berlin came up with a bold and unusual design for a high-performance interceptor aircraft that could be developed and produced far faster than anything which had come before. Berlin's scheme involved cobbling together an aircraft from parts of other aircraft then already in mass production, cutting down, at least in theory, on design and tooling time. As originally conceived, this Frankenplane used the wing panels of a Curtiss P-40E Warhawk fighter, the tail section of a Douglas SBD Dauntless naval dive bomber, and the undercarriage of a Vought F-4U Corsair fighter, with only the fuselage being of new construction. The aircraft was powered by a 2100 horsepower Allison V34 2019, effectively two V1710 V12 engines bolted together to form a 24-cylinder W-block engine. This engine had originally been developed as a potential replacement for the Wright R-3350 for the Boeing B-29 Superfortress, but the outbreak of war had caused the project to be scaled back. After searching in vain for another aircraft manufacturer to use their design, in Don Berlin's concept, GM thought they had finally found the ideal application. Berlin mounted the engine in the rear fuselage behind the pilot, with power being transferred to the aircraft's twin, nose-mounted, contra-rotating propellers via two long drive shafts running under the cockpit, a similar arrangement to the Bell P-39 Airacobra fighter. Unlike the Airacobra, however, which had a tricycle landing gear, Berlin's design was a conventional tail dragger. The cockpit was thus placed far forward on the fuselage to improve visibility during takeoff and landing. The aircraft was projected to have a top speed of 704 km an hour at an altitude of 6,000 meters, a rate of climb of 1,700 meters per minute, and a range of 3,600 kilometers. It was to be armed with 10 50 caliber machine guns, 6 in the wings and 4 in the nose, firing through the propeller, as well as two 500-pound or 227-kilogram bombs mounted on underwing hardpoints. On September 10, 1942, GM approached Major General Oliver P. Eccles, commanding officer of the Army Air Forces Materiel Command, with their proposal. At the time, the USAAF was desperate for new high-performance fighter aircraft. The Curtiss P-40 was proving increasingly outmatched by newer generations of German and Japanese fighters, while the Republic P-47 Thunderbolt and Lockheed P-38 Lightning, then under development, were experiencing a host of teething problems and would not be combat ready for another year or so. GM, by contrast, claimed that its new aircraft could be ready for flight testing in as little as 6 months. As a result, General Eccles readily agreed to a cost-plus fixed-fee contract of $428,271 for the development of 2 prototype aircraft designated the XP-75 Eagle. Though the concept was radical and untested, Eccles was confident that in the hands of an experienced designer like Don Berlin, everything would work out. To develop and build its new fighter, GM chose its Fisher Body Division in Cleveland, Ohio. At this time, this division was occupied building engine cowlings, outer wing panels, ailerons, flaps, horizontal stabilizers, elevators, vertical stabilizers, rudders, as well as 200 complete airframes for the Boeing B-29 Superfortress. However, the Army Air Forces assigned the XB-75 project a higher priority, allowing GM to clear out the B-29 production line and transfer it to the Glen L. Martin Company in California. Initial progress was swift, with the first full-scale mock-up of the XB-75 being ready for inspection on March 8, 1943. By this time, however, the Army Air Force's requirements had changed. Attacks by enemy bombers had become less of a threat, greatly reducing the need for high-performance interceptors. At the same time, however, the Allied strategic bombing offensive against Nazi-occupied Europe was ramping up, and the Army Air Force feared that existing long-range escort fighters might soon be outperformed by newer versions of the German Messerschmitt Bf-109 and Focke-Wulf Fw-190 fighters. They thus requested that GM adapt the XB-75 to the long-range escort fighter role. On July 6, they also increased the initial prototype order from 2 to 8 and issued a letter of intent for a mass production order of 2,500, giving GM a head start on the construction of jigs, fixtures, and other equipment. A definitive contract was soon signed, stipulating that the first prototype would fly no later than September the 30th, the long-range XB-75A prototype no later than December 1943, and that full-scale production would begin in May 1944. The contract laid out a price of $4,450,702 for the first 8 prototypes, while the total cost of the production models was estimated at $325 million, which is nearly $6 billion in today's money, not counting the Allison engines which would be furnished by the US government. However, it also granted the Army Air Forces the power to cancel the entire project should GM's aircraft fail to meet expectations. But while GM was confident in its ability to deliver on its grand promises, it was soon to be reminded that making airplanes is oh so very different from making cars. While Don Berlin's original design used P-40 wing panels, this was soon switched to more readily available panels from the North American P-51 Mustang, requiring extensive modifications to the assembly jigs. The original Vought F4U Corsair landing gear also proved too heavy and had to be replaced with lighter units from the Douglas SBD Dauntless. These changes resulted in the delivery of the first prototype being delayed until November 1943. The aircraft made its first flight at Wright Field in Dayton, Ohio on November the 17th with test pilot Russell Thor at the controls. The results were less than encouraging, with the Eagle proving underpowered, sluggish to fly, and prone to entering dangerous spins when performing tight turns, all characteristics you might recognize as less than ideal for a fighter. But GM was undeterred. After all, even the best aircraft have their early teething problems. Returning to the drawing board, Don Berlin and his engineers improved the XP-75's lateral stability by enlarging the area of the vertical stabilizer. However, this precluded the use of the stock, mass-produced SVD tail unit, robbing the design of one of its primary advantages. This change also shifted the aircraft's center of gravity forward, forcing the engineers to extend the nose section to compensate. Other modifications were also made to adapt the aircraft to the long-range escort fighter role, such as retuning the engine, adding additional fuel tanks, installing a retractable tail wheel to reduce drag, and changing the original heavily framed cockpit canopy to a one-piece bubble style for improved visibility. The improved XB-75A prototype was completed in December 1943 and made its first flight on January 24, 1944. Once again, however, the aircraft's performance proved lackluster. The situation was made even worse when on April 8th, the third prototype crashed during flight testing, killing test pilot Hamilton Wagner. In response, Don Berlin extended the ailerons to the wingtips to improve roll stability and added hydraulic boosters to reduce control forces. But as with the tail modifications, these modifications prevented the use of stock P-51 wing panels as originally intended. On June 7, 1944, the Army Air Forces issued an official contract for 2,500 production P-75A aircraft. Official performance trials began soon after, but once again, the results proved disappointing. The Eagle could reach only a top speed of 673 km per hour, 31 km per hour slower than predicted, and a climb rate of only 914 meters per minute, far short of the 1700 it had been designed for. Meanwhile, the Republic P-47N Thunderbolt was achieving speeds of 740 kph, despite being fitted with long-range fuel tanks for escort duties. Furthermore, the Allison V-34 2019 W-24 engine continued to cause trouble, being prone to overheating and other issues. Indeed, on August 5, 1944, the engine in one prototype suffered a mid-air explosion, tearing the empennage free of the aircraft. Thankfully, however, the test pilot Russell Weeks managed to bail out safely. Fellow test pilot Harry Bolster, however, was not so lucky. On October 10th, 1944, Bolster's aircraft suffered a massive gearbox failure, causing the propellers to snap into a flat pitch. Though Bolster attempted an emergency landing, he was unsuccessful, dying instantly on impact. But while testing carried on, no matter what GM's engineers tried, they could not get the Eagle to work properly. In retrospect, this is hardly surprising. After all, with a length of 12.3 meters, a wingspan of 15 meters, and a gross weight of 8,260 kilograms, the XB-75 was a big aircraft, one cobbled together from parts of very different aircraft and powered by an experimental and highly temperamental engine. However, having been conned into supporting this boondoggle, Major General Eccles was keen to blame everyone but himself and GM and lashed out at the Wright Field flight testing team, accusing them of using faulty methods and having unrealistic expectations. But no amount of finger-pointing could obscure the hard truth. For all its lofty promises, GM's Eagle was, in fact, a turkey. Finally, on October 4, 1944, Lieutenant General Barney M. Giles, Chief of the Air Staff, signed an order officially terminating the performance trials and the entire XP-75 contract. In addition to the aircraft's dismal test performance, experiments had demonstrated the feasibility of fitting the North American P-51 Mustang with long-range fuel tanks, allowing it to take over the bomber escort role. There was, therefore, no longer any need for the XP-75. In total, the fiasco had cost the US taxpayer some $50 million. That's nearly $1 billion today. And for this eye-watering sum, the Army Air Forces received only 8 prototypes and 8 production P-75s, none of which ever saw combat. The 6 production aircraft were retained for experimental purposes, being used to further develop the V-34 2019 engine. However, while the engine was installed in a handful of experimental aircraft, it too proved a costly failure, with the testing program claiming 1 more aircraft and test pilot. Only 150 engines were built before the project was finally cancelled. Today, only 1 XB-75 Eagle survives, preserved in the National Museum of the United States Air Force at Wright-Patterson Air Force Base in Dayton, Ohio. The story of the Fisher P-75 Eagle stands as one of the most pathetic sagas in the history of the U.S. aviation industry. A dismal failure which Lieutenant General Franklin O'Carroll, Chief of Engineering at USAAF Material Command, blamed on, quote, incompetent personnel at General Motors who requisitioned large amounts of government-furnished equipment, difficulty in handling government-furnished equipment, and original overly optimistic estimates made by Fisher Body, end quote. Historian Stephen Wilkinson was even less charitable, writing in 2020 that, quote, the Fisher XP-75 Eagle was the worst aircraft that US taxpayers bought during World War II. When the P-75 program was finally shut down in October 1944, only 14 unarmed, useless aircraft had been manufactured. Estimates vary wildly as to how much each airplane cost, but the kindest guess is about $9,375,000 in current money. The Republic P-47 Thunderbolt, which the P-75 was intended to replace, went for roughly $1.2 million in today's money. So, how could this have happened? Blame it on stupidity, greed, poor management, an unfortunate engine choice, and an overrated aircraft designer. End quote. But while this is the official narrative, it is possible that the XP-75's dismal failure was actually GM's goal from the beginning. According to military historian and author Bill Yen, at the time, GM was feeling overstretched by its wartime production duties, especially the production of the B-29 components and airframes at the Fisher Body Division. Its executives thus cooked up the XP-75 as a high-priority project to free them from this responsibility. While this theory is debated by historians, if true, then GM's scheme was successful. As mentioned before, Fisher's B-29 assembly line was transferred to the Glenn L. Martin Company in California, and not a single Superfortress component was manufactured by GM for the remainder of the war. Alleged shenanigans aside, however, GM was hardly slacking on the job. Though conversion of the Eastern Aircraft Division plant at Linden, New Jersey, only began in January 1942, by September of that year, the first Grumman F-4F Wildcats were already rolling off the assembly line, with the first TMB Avengers following 2 months later. By December 1943, Eastern Aircraft had produced its 1,000th Avenger, and by 1944, its 2,500th Wildcat. Meanwhile, while rival Ford never came close to achieving their founder's boast of 1,000 aircraft a day, their gargantuan Willow Run plant at Ypsilanti Township, Michigan, nonetheless achieved a manufacturing miracle, producing 6,792 consolidated B-24 Liberator heavy bombers at the extraordinary rate of 1 aircraft every hour. These numbers speak to the Herculean lengths American industry went to in order to support the war effort and secure final Allied victory, and go a long way toward excusing the occasional misstep like the Fisher XP-75 Eagle. Indeed, for all its faults, the XP-75 was far from the worst military aircraft to ever be sold to the US government. And to learn what was and discover an even more unbelievable story of skullduggery and woe, please do check out our previous video, The Worst Military Airplane Ever.